These questions are coming from acid and bases. So we have question 1, which is asking us to find the pH of 0.25 molality of hydrochloric acid solution, 3 marks. So before you answer the question, you need to identify if you're dealing with a base or an acid. So how do you identify? So if you decompose this one here, or if you write the ionic equation of that, of hydrochloric acid, what are we going to have? We are going to have hydrogen ions plus chloride. So chlorine, it doesn't contribute to the acidity of the solution. What contribute to the acidity of the solution are just two things: hydrogen ions and hydroxide ions. So if you have more hydroxide ions, meaning to say the solution is basicity or is basic. When you have more hydrogen ions, meaning the solution is acidic. So that is one thing that you need to know. So when you have a question like this, we need to identify. So we're dealing with an acid for the first question. So what we are going to do here, this is the solution of hydrochloric acid, but we don't know the solution of hydrogen ions. So in finding pH, the formula is this one: pH is equal to the negative log of hydrogen concentration, or you can say negative log of hydronium ions. They are just the same. So whichever way, but here we are dealing with hydrogen ions, so we need to find the concentration of hydrogen ions. How? We are going to compare the ratios. So we have 1 to 1 to 1. So if this one is having 0.25 molality, even this one is going to have 0.25 molality, even this one is going to have 0.25 molality. Why? Because it's a 1 to 1 ratio. So we know now the concentration of hydrogen ions here, which is 0.25 molality. So you can use the formula for us to find the pH: negative log of 0.25. Then what are we going to have? So it's just a matter of us punching now, then find your value. So me, I'm getting 0.6 as our pH. So this is how you're supposed to find the answer for the first part. What about the second part? So even the second part, you need to identify if the question is involving an acid or if the question is involving a base. So it is saying calculate the pH of 0.25 molality of calcium hydroxide solution, 3 marks. So we're dealing with calcium hydroxide. Is calcium hydroxide a base or an acid? It's a base. So if I decompose this one, I'm going to have calcium ion plus hydroxide ions. So the reason why I'm writing a 2 here, this is because I have a 2 here to balance up the number of the moles, to balance up the moles. Yeah. So if you can just count the number of moles that we have 2 hydroxide here, even here we have 2 hydroxide. Then when it comes to calcium, it's 1 to 1. So the ratio is 1 to 1 to 2. So we have 0.25 molality. So even here we are going to have 0.2 molality, but here we are going to have 2 times 0.25 molality. That's the concentration of hydroxide ion. So if I multiply, I'm going to get 0.5 here. So meaning to say that 0.5 is the concentration of hydroxide ion. But when you're finding pH, you need to have the concentration of hydronium ion, or you need to have the concentration of hydrogen ions, but we don't have that. So what are we going to find? We're going to find pOH. We know to say pOH is a negative log of hydroxide ions. Then another relationship that you need to know is that pH plus pOH is equal to 14. So meaning to say that if we find the pOH, just very easy for us to find pH. We need to take this one to the other side. So let's find pOH, because we know to say that pOH is a negative log of hydroxide ions, which is 0.5. Let me just say the negative log, like that. Need to write negative log, then 0.5. So negative log of 0.5 I'm getting 0.3. So 0.3 is our answer for the pOH. But what about the pH? So pH is going to be equal to 14 minus 0.3. The note is going to be our answer. So 13.7 is our answer. So no units. So that is our answer for the pH. So that is how you're supposed to answer that. What about the second one? So the second one is interesting because it's involving the mixing of bases. So you need to be very careful on this one here. They like asking this question, so pay attention as I'm explaining. So what is the pH of the solution prepared by mixing 10 mL of 0.015 molality of barium hydroxide as well as 30 mL of 7.5 multiplied by 10 to the power negative 5 molality of sodium hydroxide. So we are dealing with bases here. So let me just separate them. At first we have barium hydroxide. And then secondly we have sodium hydroxide. So what things do we have? So we have volume 1, which is 10. So if I convert that one in liters, so you need to divide by 1,000, so it's going to be 0.01 liters. What about molality number 1? It is in its appropriate unit. What about this one, volume number 2? We have 30, so I need to divide by 1,000. Then I'm going to get 0.3 liters. What about molality number 2? 7.5 multiplied by 10 to the power negative 3 molality. So this is what we have. So what is the next step? The next step, you need to calculate the number of moles before you write the decomposition reactions or the ionic equations of these ones. So number of moles is equal to concentration multiplied by volume. Yeah. So we have concentration here, which is 0.015 molality multiplied by the volume, which is 0.01 liters. What about this one? We have the volume, this one has to be 0.03. What about this one? We have the concentration, which is 7.5, that then multiplied by 0.3 liters. That is what we have, isn't it? So now let me do the computation on this side. So on this side I'm getting 1.5 multiplied by 10 to the power negative 4 number of moles. Just finish this one. And then here we are multiplying this one by 0.03. Okay. Here I'm getting 2.25 multiplied by 10 to the power negative 4 molality. Or moles, not molality but moles. So these are the number of moles of the first one, barium hydroxide and sodium hydroxide. So what are we going to do? Let's decompose now those. Let's write the ionic equation for those bases that we have. So this one is going to yield barium ions plus 2 hydroxide ions. Then for sodium hydroxide, this one is just direct. We have sodium ions, also have hydroxide ions. So if you see the ionic equation, it is balanced. So in terms of the ratio, it's 1 to 1, even here, but means it's 1 to 1. And then this one is 2, not 1 to 1. It's 1 to 1 to 2. then this one is 1 to 1 to 1. So this is what we have. So in terms of the concentration of hydroxide ions here, we need to multiply by the molality. Let me say the number of moles of barium hydroxide for us to know the number of moles of hydroxide ions. So we have 1.5 multiplied by 10 to the power negative 4 moles. So this one is going to give us 3.0 multiplied by 10 to the power negative 4 moles. What about this one? Is 1 to 1. So meaning to say this one is having 0.25 multiplied by 10 to the power negative 4 moles. Even this one is going to have the same. Even this one is going to have the same. So for hydroxide on that part, it is this one. So what is the next step? We need to find the total. Since we are combining barium hydroxide and sodium hydroxide in the same beaker, so there is a combination. So meaning to say that the volume is going to be additive as well as the number of moles are going to be additive. So this is what we have in the beaker. Okay. So the volume is additive. Apart from the volume being additive, even the number of moles are going to be additive. So let's find the total number of moles of these two. So I'm going to add this one, which is the hydroxide, the number of moles of hydroxide ion for barium hydroxide plus 2.25 multiplied by 10 to the power negative 4 moles of hydroxide coming from sodium hydroxide. Then when I add, I'm going to get 5.25 multiplied by 10 to the power negative 4 moles. So this is the total number of moles. What about the total volume? Since volume is also additive, so we have 0.03 plus 0.01, which is approximately 0.04 liters. So this is what we have. So we can find the number of moles. Let me say we can find the molality. Molality, which is concentration, is equal to number of moles divided by volume. So number of moles is 5.25 power negative 10. Let me say negative 4. Then we're dividing by this one. So what are we going to have? So I'm getting 1.3 multiplied by 10 to the power negative 2 molality, or moles per liter if you want. So this is denoting the number of moles of hydroxide as the combination. Remember, we are calculating the pH. So before we calculate the pH, let's find pOH, because we know to say that pOH is a negative log of the hydroxide ions. So you just need to punch on the calculator and then you see what you are going to have. So for this one, negative log of the answer, I'm getting 1.9, which is just approximately 2.0 as the pOH. What about the pH? pH is going to be equal to 14 minus 1.2. That means 1.9. So 14 minus 1.9. I'm getting 12.1 as my pH. So that is how you're supposed to answer that question. Very simple. Let's see other questions. Let's erase this. So for the second question, we have been given nitrous acid, and it is saying nitrous acid was diluted. So here, I think you need to have ideas on dilution law. So dilution law states that if you multiply volume 1 with concentration or molarity number 1, this one is going to be equal to volume number 2 and molarity number 2. Or you can use V and C if you want. They are just the same. So we have 10 moles of 1 molarity at first. So volume 1 there is 0.01. If you convert 10 mils into liters, this is what you're going to have. Then molarity number 1 is 1. What about volume number 2? So volume number 2 we have, which is 0.1 liters if you convert that. What about molarity number 2? We don't know, we don't have. So the question is saying calculate the pH of 10 mils of 1 molarity solution of nitrous acid diluted to 100 mils with water. So the question is saying with water, for which pKa, let me say Ka is equal to 6.0 multiplied by 10 to the power negative 4 at 25 degrees. So at 25 degrees Kw, which is the ionization of water, is 1.0 multiplied by 10 to the power negative 14, negative 12, 14, yeah, something like that. So here you need to find what molarity number 2 is. So using this formula or this formula, you are able to calculate what molarity 2 is. Let me say this is molarity number 1. Yeah. Then volume number 2. So molarity number 2 is going to be equal to, so we are multiplying 0.01 multiplied by 1 divided by 0.1. Then what am I going to get here? So I'm getting 0.1 molarity. Okay. So let's type now the ionization reaction, or let me say the dilution reaction of nitrous acid plus water. Then see what we are going to have. So we have nitrous acid reacting with water. And then what are we going to have? We're going to have hydronium ions plus nitrous. This one has to be, just to this one. I need to remove H there. Need to remain with nitrogen oxide ions. So nitrogen oxide ions, that is what we are going to have. So in terms of the ratio, is 1 to 1 to 1 to 1. So actually this question is supposed to have 2 IC table, but I'm just going to draw one to make things very easy for you. So if nitrous acid is having 0.1 molarity, so even this one is going to have 0.1 molarity. Let me forget about this one, not this one, but rather on the product here. This one is going to have 0.1 molarity. Even this one is going to have 0.1 molarity. Okay, but we can't tell. This is for the first table. This is the first table where they are going to equal to each other. What about the second table now after dilution? After dilution, you don't have what the concentration of these are going to be. So you need to draw the IC table. So this is the second IC table. So ICE table, where I denote the initial, then C denote change, and then when it comes to E, it denote equilibrium. So this is what we have. So we have nitrous acid. We also have hydronium ions, nitrogen oxide ions. So after dilution, here we are going to have 0.1, here we are going to have 0, even here we are going to have 0. The first table is the one which is going to contain 1, 1, 1, 1, 1. Or let me say 0.1, 0.1, and so on. But the second table, this is the second table which I'm drawing for the IC table. just going to have 0, 0 on this part. So in terms of the coefficient here, we just have 1, 1, 1, 1. So meaning to say there is a reduction in terms of the reactants, and the products are increasing. So we need to forget about water because water is a liquid part. So we say minus 1, then plus x, then plus x. So we say minus x, not minus 1, then here plus x plus x. So in terms of the change, we are going to have 0.1 minus x, then here x, then here x. What is our Ka expression? Ka expression is equal to product over reactant. So in terms of the product that we have here, we have hydronium ion and nitrogen oxide. And nitrogen oxide ion. Then on the down part for the reactant, we have nitrous acid. So this is what we have. But remember, the question has given us the value of Ka, which is 6 multiplied by 10 to the power negative 4. So we can replace 6.0 multiplied by 10 to the power negative 4. Then this is equal to. So here we are going to focus on the equilibrium part. What do we have on the equilibrium? So remember, this is nitrous acid. This is the hydronium ion, and this is the nitrogen oxide ion. So in terms of hydronium ion and nitrous acid and nitrogen oxide ion, we just have XX. Then on the down part we have 0.1 minus x. So here you need to assume that on the down part here, you need to assume that that value of x is less than so you need to assume that x is less than 0.1. So if it is less than 0.1, meaning you can work out with this one. And why are we assuming here? We are avoiding to go the method of a quadratic equation. So that's the reason why we are assuming here. Okay. So you assume according to the number that you have on this part. So if you're having 2, you need to say assume x is less than 2. Don't just say 0.1. Just depend on the number that you have. So if we assume that this one is less than 0.1, meaning to say that it is going to be insignificant. So if it is insignificant, what are we going to remain with? We're going to remain with this. If you multiply, that is x squared, then this is 0.1. So if I multiply, what are we going to have? X squared being equal to 6 multiplied by 10 to the power negative 5. Then I need to find the square root here. So x is going to be equal to root of 6 exponent negative 5. I'm getting 7.8. 7.8 multiplied by 10 to the power negative 3. So this is the value of x. Now that according to this equilibrium here, the value of x is this one. So if here we had a 2 or a 3, you need to multiply 3 multiplied by the value of x for you to find the concentration of hydronium ions. So we can easily find now the pH. pH is going to be equal to the negative log of hydronium ions. So negative log of hydronium ions, we have 7.8 multiplied by 10 to the power negative 3. And then what are we going to have? So I'm getting 2.1. 2.1 as my pH. So that is how you're supposed to answer that. Now, let's answer the last question. I think it's the last one. But one thing that you need to know here is that sometimes in the question they can talk about an acid, but they are going to give you the value of Kb. So Kb focuses on the bases. But let's say, for example, the question is talking about an acid, and the way they have mentioned in this question to say that at 25 degrees, so you know the value of Kw. So Kw is equal to Ka multiplied by Kb. So in the question like this one, if this one was our Kb, okay, so you need to find Ka. because the question is talking about an acid. If in the question they have given you Ka, but the question is talking about a base, you need to find Kb. So you know the value of Kw at 25 degrees Celsius. And here they have given us Ka. So it is very easy for us to find Kb when the question is talking about a base. So let's see the last question. So the last question is saying calculate the pH of a 0.2 molarity solution of methylamine, which is this one. And then the Kb we have been given that. So let's write the neutralization reaction of this, of methylamine. So we are reacting, not neutralization reaction, but rather we are reacting it with water, and then see what we are going to have. So this one is going to donate 1 hydrogen, so it's acting as an acid. Then we can have something like this, and then here we are going to have 3, then to the power positive. So this is what we have. So the expression of Kb is going to be equal to the hydroxide ions, then we also have methylamine ions, which is a deuterium amino acid, because it has a positive charge now. It has gained 1 proton, then divided by the methylamine. So here you don't include water because water is a liquid part. For liquid part we just ignore it, or we just consider it to be 1. So we don't focus much on that. So let's write the IC table. So IC table, so we have methylamine, we also have hydroxide, we also have methylamine ion. So this is what we have. So initially what do we have? So initially we have 0.2 of methylamine, then 0 hydroxide and 0 methylamine ion. So in terms of the ratio, it's 1 to 1 to 1 to 1. So it's minus x, then plus x, then plus x. You know the reason why we're adding plus x. So let's say for example, if here we had a 2, so you need to say plus 2x. Just depend on the coefficient that you have. It's not always minus x plus x, no. Just depend on the numbers that you have. The change here is 0.2 minus x, then here x, and then x. Meaning to say that our Kb is going to be equal to x, then here 0.2 minus x. So even here you need to assume that x is less than 0.2. So if you assume that x is less than 0.2, meaning to say you need to ignore about that part, this one here. So what are we going to have? So we have 3 multiplied by this 3 to the power negative 4. Then this one is going to be equal to x squared and then divided by 0.2. So here we are going to multiply 0.2 multiplied by 3 exponent negative 4. So I'm getting, so x squared is equal to 6 multiplied by 10 to the power negative 5. This is what I'm getting. Okay, so finding the square root of this, it is going to be the answer. So I'm getting 7.75 multiplied by 10 to the power negative 3 as the value. Okay, so we know to say that here we are dealing with the pure, we are dealing with hydroxide ion. We are not dealing with hydrogen ion. So the first thing we are going to find the pOH. Let me say the pOH, which is equal to the negative log of hydroxide ion. So in this case it is 7.75 multiplied by 10 to the power negative 3. So negative log of the answer I'm going to get 2.1. So this 2.1, I need to less it from 14 for me to find the pH. Okay, so I'm getting 11.9 as my pH. So this is how you're supposed to answer this question. Thanks for watching. I think I've made a mistake here. So let's see. Yeah, I've made a mistake here. This one was supposed to be 3.3. Let me say 3.6, not 3. That one. Let me do this. Let's control that mistake, because it can cost us. So we have 3.6 instead of 3.0. So we are multiplying now with 0.2. So here now I'm going to get 7.2 multiplied by 10 to the power negative 5. Then finding the square root, x is going to be equal to 8.48 multiplied by 10 to the power negative 3. So this is the value of x. So meaning to say that it is also equal to the concentration of hydroxide ions. So I can find the pOH, which is negative log of the same value that we have. So I'm getting 2.07 as my answer for pOH. What about pH? So 14 minus the answer. Okay, still I'm getting 11.9, close.